Complex numbers. Solving quadratics involving complex numbers. We've solved quadratics in Unit 4 by graphing, factoring and using the zero product rule, the quadratic formula, and completing the square. You can use most of those methods, not so much the factoring, but the other methods, when you've got complex solutions. Now, some of this has been taken from Regents Prep, and some of it has been combined with notes that I've always had. When the roots of a quadratic equation are imaginary, meaning that they will not be crossing the x-intercept, they will always occur in conjugate pairs. The key word here is pairs. The fact that they happen in pairs means that you'll always have two of them, plus and minus. If a quadratic equation with real number coefficients has a negative discriminant, the two solutions to the equation are complex conjugates of one another. So that also means that if you know one, you know the other. So, given the quadratic equation, you can use the quadratic formula to solve it. Most of the time, this is what you will do when you are finding complex roots. Here's an example. If you find the solutions of x squared over 2 equals 5x minus 17. First, write it in standard form, which means that you're going to set it equal to 0, and then you're going to get rid of the fraction by multiplying by 2. You then have x squared minus 10x plus 34 equals 0. A is equal to 1, B is equal to negative 10, and C equals 34. Now, if you didn't know this had a complex solution, the first thing you might do is say, can I factor this? Are there any factors of 34 that will add up to negative 10? 34 only has 1 and 34 and 2 and 17. Neither of those combinations will get you to negative 10. So therefore, you're going to go ahead and use the quadratic formula. Using the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Please don't forget, even though b is negative, when you square a negative number, you still get a positive number. You then wind up with negative 36 under the radical. Well, we learned that the square root of negative 36 is 6i. Remember that this becomes the square root of 36 and the square root of negative 1. You can still do plus or minus. I don't care if you show your answer with the plus or minus or separate it into two answers. You need to know that both of these are legitimate answers and they're the same thing. On things such as SATs, ACTs, SOLs, you never know how that multiple choice answer might appear. A second example, 3x squared plus 10 equals 4x. Again, standard form. You need it in standard form. So that gets it equal to 0. And you want it equal to 0 because when y is 0, you'll be on the x-axis. You then look at factors of 30 that will add up. First thing you might check, factors of 30 that will add to negative 4. There aren't any. Therefore, you're going to resort to either the quadratic formula or completing the square. You go through the process and you wind up with 4 plus or minus the square root of negative 104 over 6. Separate out the negative 104. It's negative 4 times 26. From the negative 4 you get 2i, and then the 26 stays under the radical. You should not have to continually break apart the negative from the 4 when you're solving. Your final answer, either this with the plus or minus, or here with plus and then minus. Remember that it's two separate solutions. Example 3. This one looks a little funny. You have x plus 5 over x equals 3. If you multiply each term by x, you eliminate the fraction, and you wind up with an equation that you can put in standard form. Then you look at positive 5, and are there any factors of positive 5 that add to negative 3? Your answer is no. So you keep going. You do the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, you want to keep saying this or write it down so that you start remembering it. It should be something you can almost say in your sleep. Okay? When y is 0, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When you put the numbers in here and solve it, you'll get 3 plus or minus I root 11 over 2. And you can break that up into this form. This is considered the a plus bi form. I will take the answer in either form. Now, you should try some. Pause the video and try this one. X squared plus 10x plus 29. 29 is prime. 1 and 29, there's no way to get to 10. So, what's the solution? Quadratic formula. Here's the answer. Hopefully you paused and you tried it. Notice, when you get down here to the bottom, you need to reduce the fraction. 2 will go into each and every term. Whatever's in the denominator has to be able to go into both terms. It can't just go into one in order to reduce. And again, you could put your answer in the a plus bi form. Here's another one to try. And this time, go ahead and express it in the a plus bi form. Pause the video. And you're back. Let's check it out. Okay, realize first, and we're going to go down the left side and then down the right. First thing, you need to get rid of the fractions. So you multiply every term or both sides by 4. Then you move everything to one side or the other. Once you've done that, you've got it in standard form, and so you can set up to solve the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplify it. Remember, take care of simplifying the negative and negative. That's your positive. The negative 8 quantity squared is 64 minus 4 times 1 times 40. You wind up with negative 96 under the radical. Negative 96, when you put it in simplest radical form, the negative 16 breaks out and you get the 4i. Simplify your fraction. And here's your answer in a plus bi form. Now, what about quadratic equations that can be solved by simply taking the square root of a value? Well, let's look at a couple of these examples. This first one, we have 4x squared is equal to negative 25. X squared is equal to negative 25 over 4. I take the square root, so x is equal to plus or minus the square root of negative 25 over 4. Okay, you got a negative underneath, so you're going to get the I out, and additionally, you're going to get 5i over 2. Okay, keep the I in the numerator. So plus or minus 5i over 2. The next one, we have 2x squared equals 100. Oops, equals negative 100. X squared is equal to negative 50. 100 is divisible by 2, so do divide it. Now I have x is equal to plus or minus the square root of negative 50. X is equal to plus or minus 5i square root of 2. Remember that 50, I can break that up to negative 25i and 2. Okay, finally, 36x squared plus 100. 36x squared equals negative 100. Divide both sides by 36. "36 does not go evenly into 100, so we leave it, and we get x squared is equal to plus or minus the square root of 100 over this, negative 100 over the square root of 36. This is equal to plus or minus 10I over 6. Without the square. Can you do anything else? Sure you can. You can reduce that fraction. In this case, x is equal to plus or minus 5I over 3. Don't forget to reduce fractions all the way. Okay, those were 3 different examples where you could simply use square roots, not the quadratic formula. So try solving for this one. Pause the video and try this one. Hey, you're back. And how did you do? Hopefully you did great and you got plus or minus 7I over 2. Now, remember completing the square? You can do that as well, and you can still get imaginary or complex solutions. Pause the video and try these 4. When you think you have them, start the video again, and I'll display the solutions. Okay, you're back. Here are the first 2. Don't forget what you add to one side, you have to add to the other side. So you added 16, you have to add 16. Added 9, you got to add 9. Simplest radical form. Over here and here. There are these 2. Hopefully everything works out. You got the answers. If you still have some questions, make sure you bring your notes in with you and the problems that you've tried, and we can do some more in class. In summary, to solve a quadratic that has complex roots, the quadratic formula can be used. You simplify the quadratic first. To solve a quadratic that has complex roots and is of the form ax squared plus c, where there's no b term, there's no linear term, you can simply use square roots to solve. When solving a quadratic by completing the square, the result could include the square root of a negative number, and that would result in a complex solution. All right, hopefully you've got it all.